Okay. So welcome team, session 5, GenAI training. So today we'll talk about the RAG architecture. So in the last about four sessions, we have talked about um, the GenAI prompt engineering. Then we talked about embedding models, and then we talked about vector databases. We built some semantic search applications, right? So now, the extension to the semantic search application is your RAG architecture. So when you add a language model to the semantic search application to answer the questions, then it becomes your complete RAG model. Of course, there are few um, flavors or variations to it where you can also combine a RAG with a vector database as well as a SQL database further to filter the results, with the term called hybrid RAG. But that's just the another term to add more components to the architecture. Okay, so let's look at what is RAG. I think we should go back here. Yeah. So we looked at this architecture, right? So this is what we're going to do this week and also next week, 4 sessions. So we looked at this, um, and then we have talked about some of these components last week. Anybody who wants to summarize what part of this we have completed, uh, what we have built last week?
Yeah, we have converted the raw questions into embeddings and we are stored into vector databases. And
Mhm.
then we are trained data also converted into embeddings and stored into vector databases. That two part we have done. Yeah, but we are trying to find out the relevant uh,
Okay,
question. But yeah,
awesome.
we did not get the answer yet now. So we are now looking for the to get the answer.
Exactly. All right, great. Okay, so you're right. So we took some raw data sources, which is, I mean, the example we took is a PDF document, just my resume, and then they extracted the data using some of the all the part on the left is all pure, using some Python libraries. We did extraction, some text splitters libraries we used to split the text into words, number of words we provided, chunking, and then we call an embedding model to generate the embeddings, and then we used vector database. Towards the end, we used FiceDB, we used Chroma, but towards the end, we used a Pinecone database, right? And we put the embeddings into the vector database. Okay. And then we asked a question, user query, and then we converted the query also using the same embedding model into an embedding and did a vector search using a retriever, and then we got the relevant data out. So till this part we were completing. So this completed. So this is all like a semantic search application. So as is also you can use in a lot of applications. But in terms of GenAI, where we want to answer a specific question in terms of language, natural language, there's still some work to do. So this is kind of a raw data that we are getting, but we are getting from our own sources, and we are getting filtered data. So based on the relevant results from our data, right? So this is just another representation of the same model. Okay. Documents, chunking, embedding model, storing in vector database. We are representing here. This is VV8. And then query also, we sent it to embedding model, and the embeddings we got. So we search actually and then get the relevant results. Then query as is text also, we are uh, adding it to a template. prompt template. I know in earlier sessions also, somebody asked what is the prompt template. So we are going to see what is the prompt template, what it has. So that there's a query text, there are search results, and there is some system instructions. We send it to large language model to look at it and then respond. Okay, so this is the same RAG model, just different representation here. So RAG is just a retrieval augmented generation. Is an AI framework that combines information retrieval with text generation to improve response accuracy. So it combines, it augments your input data, just like we said, instead of giving a 1,000-page document or relying where, so two things. One, the LLM will not have your personal data, so there is no way that it can answer anything. So any model will not have what are the projects I have worked on, right? So if I say what are the projects I have worked on, it will not have an answer. Or say what are the certifications that I have, it will not have an answer. Of course, there is a way. If you build an agent and you give a web tool and you ask it to scrape my LinkedIn, and if I have mentioned all my badges and certifications on the LinkedIn, yes, the agent can use the tool to go read my LinkedIn scraping website profile and then try to get the relevant information about my certifications and badges I have got and then give you an answer. So that's a different topic. But LLM on its own does not have the knowledge, right? So for that purpose, we are augmenting it. We don't have personal information. So we have to provide that if we want to answer a question related to our personal information or organizational information or data, right? Sensitive data. The second part is, even if you have that, as I said, we don't want to dump a 1,000-page document for it to read and then answer the question. It can, but it needs resources to train and retain all of that knowledge in the LLM. Instead, what we do a temporary memory. Okay, we created a RAG, so we split all the 1,000 pages into probably one page chunk, right? Parts, and then based on the question, we are only extracting those pages where the related information might be available. And 3 or 4 pages we will take and then give those pages to the model, LLM model, to go through those 3 or 4 pages and answer the question. That's it. That's simple, RAG. Why it matters, as we said, LLM have limitations in knowledge cutoffs. RAG helps bridge the gap. Chatbot retrieving up-to-date company policies before responding. And it has a fixed knowledge base, training data limitations that it has. Obviously, LLM cannot be trained on all organizational data of the entire world. Of course, it's not feasible, it's not allowed. Nobody will give your data publicly to train the LLMs, right? So that's internal training that you can do. LLM training that you want to, which is very expensive again. So it's the interim fix is to have a temporary memory where you add only the data based on the particular question that it's trying to answer your application. Inability to access real-time information, right? So use cases are legal, healthcare, customer support, and research. Legal, okay. Let's see how do you think these in these use cases, how do you think the RAG architecture will help? So let's talk about legal. Anybody want to talk about legal? Give me an example. So I have a legal attorney basically. Okay, let's say I'm attorney office, and how would the RAG architecture help me? Where I can use this?
I think general legal questions which you can ask, like for example, if you want to ask about any H1B related questions, like in the US, right?
Mhm. But I can ask that to anything, right? I cannot ask ChatGPT also. Why do I need RAG for that? Come on,
Yeah,
guys,
correct.
think.
Can you reframe your question again? I'm not sure if I understood. You are saying that as a
So,
legal or as a
yeah, if I am an attorney, so if I am an attorney office, I'm an attorney, okay, I have a business, I'm an attorney business, I have clients. How would RAG architecture help me in my business?
okay.
What use
Probably
case?
schedule a call with an attorney, which is timing.
Mhm. No, think what is RAG doing? Tell me, what is RAG doing? It's right there.
So in this case, you have your client cases, right?
Are
Those
you able to
cases,
see the screen, right?
yeah, yeah.
Okay. Yeah.
You have a history of cases, right? So based on your question, the relevant case information, it will search and then it will give us some information. Based on that, you can proceed on your current case.
Exactly. Right. So there are a lot of paralegals at the attorney. Basically, some people who do research or like interns or somebody, paralegals who do the background work for any case for an attorney. Okay. So let's say there is a criminal case and then the attorney wants to do some research based on what are all the previous cases or similar cases that the attorney might have handled, and all the information out of that, and what was the judgments and what was the uh, mm, you get context and proofs that were available. How the case went through and what arguments were there. Everything would be there. So it will all digitized knowledge, but there might be hundreds and thousands, right? So it's a big firm, or maybe a firm has 100 years. There's a lot of cases. So in that case, it's just kind of a library. So you go and search, right? So for in that cases, if all of those cases are put into a vector database, RAG, and then we ask a question about a particular case, it can pull up that information, pass it to RAG, and then it give you a summary of that any particular case. You can ask question like, say, give me all the cases where a civil suit was involved with land, right, that we have dealt with, or any particular thing cases, or something like a burglary that happened in this area, right, or a murder happened in this pattern, right? So you can ask any question, and what were the our previous case arguments and how the case processed, and all of that you get. So healthcare, so that's the use case, say legal, or you have 100-page summary that somebody has all done, and then you want to summarize that, the analysis of everything, and then give a summary to the client or to the attorney to talk about. So then you can also use that. Healthcare. You talk about healthcare. Let's say a doctor's office.
That can help the doctors to see the history of the patients before patients comes, right? Those
Yes.
data.
So they can tap into if again, it's a sensitive data. If the data is available, like you can say all the patient data, there are several 2 or 3 systems that are available in the healthcare where they store the patient data and the um, patient diagnosis data, information, and all of that. So when a new patient comes in and he talks about some of the symptoms, you can quickly check, give a question, give the symptoms, and then pull what are the cases earlier with similar symptoms, and what was the diagnosis and what was the treatment. So those kind of things that you can quickly pull, right? So that will help the doctors to correctly diagnose on the doctor's office side. On the research, basically, as we talked about multiple times in the drug discovery, in the or the cancer research or any of the research, it is very helpful to ask questions based on the previous research that has been done, research papers that are available, the drug trials and the response and the results. All of that you can use. Some models are already trained on, like I said, domain specific, but you can also still use any of this to do the answer those questions, right? And we all know customer support. That's the default basic use case. Any question about support that they ask in internal, it can be internal employee customer support. Let's say, hey, how do I create a ServiceNow ticket for installing a new software on my laptop? So it could go through the existing Confluence page or wiki page, and then give you the complete step-by-step process and also a link to click and open ServiceNow, and then you can add the ticket there. Okay, and that is where again you can have an agent take over and create the ticket on your behalf and submit it. Right, so that goes into the agentic use case. But yeah, long story short, these are all the use cases we're talking about. So what are the components of the RAG we are looking at here? Retriever. Okay, retriever is basically to get this data, to search the vector database and get the relevant information, basically your vector DB and search engines from this. Okay. Generator is your LLM actually. Embedding models convert documents into vector representations and vector database to store and search similar documents. So we have seen, so these are all the basic components: vector database, embedding model, retriever to search and get information, and LLM to do the answer. We have looked at it, product-based customer queries, questions. That's all, not much. We don't want to do beat a lot of slides on this. We'll get into action right away. Okay. Any questions before we go here?
See, what will be stored in the LLM? LLM simply will generate the data, but how it will generate the data with?
LLM, see, that is the whole purpose of having an LLM, right? So that is a model
Okay.
which is trained on all the available, publicly available information. It has the intelligence, it has built the context, it has understood everything. And based on your question and the knowledge it already has, it will answer the question. That's basically the chat GPT. It's answering your question. That's your LLM. That is using your LLM, right? So how
Yeah,
it would answer?
What I understood till now is in the vector databases will have embeddings in that it will give only the relevant question to the, right? If you ask some question, but answer we are getting from the through RAG LLM, right? So the data, it has the intelligence or all those things, but where it can get the data, it will search from the internet or something, and how from where it is
No,
get the data.
not internet. See, it reads this information from here.
Okay.
This relevant data, whatever we are getting from our vector database, from our RAG, we are sending it to the LLM model. That
Okay.
model will read all these 4 or 5 pages of information and then answer the question from that information.
You mean that our answer is also there in the vector database, and then we are getting
Exactly.
those?
Yes, that's what we are trying to do, right? We are giving it a subset of information for the LLM using vector database and throw it at 4 or 5 pages saying that, hey, LLM model, these are the 4 or 5 pages of information. And I believe the answer to the user's question lies in these 4 or 5 pages. Now you go through these 4 or 5 pages, read it, understand, extract the answer, and then respond in a logical or natural language, nice way that the user can understand. That's what the model does. So instead of answering from its own knowledge, it will only answer based on what information you are providing to the LLM.
So Syed, is it only based on relevant data information, or it's based on some of the information from the internet as well? Like
RAG is
consider
meant, okay, RAG is meant for only relevant, to give you answer from relevant information. If
not
you
the RAG.
want,
I'm
you can
asking about
also
LLM.
instruct. Yeah, if you want, you can also instruct the LLM model to use its own knowledge as well, in general. But here we want to answer only from specific information that we are providing. Okay. Now there is another question in the chat, Nitin. LLM has come cutoff knowledge. So do we need to upgrade? So yes, LLMs have cutoff knowledge. We cannot keep updating that because that is part of your model training, which is expensive. It's not like we cannot, we can. It's expensive part. That's what the companies do. They release a model. Okay. So let's say it's like a car. Okay. You bought a car, you have all the latest features. Now the company is continuously working on improving that car, right? So the next year, the same car comes out, it has more features. But once you bought your car, you cannot have those features in your car, right? You can go and customize it, add, say, initially the seats does not have warmers. Okay. Now the new version of the car has got warmers. But can you get the warmers? Yeah, you can go to some shop, custom shop, pay $10,000 or whatever and install warmers in the seat. It's very expensive and not convenient. Now, instead, if the customer, if the manufacturer is giving you in the next version seat warmers, right? It's the next version. It's an upgraded version. Now you can exchange your car or return your car, or like iPhone. A new feature comes in, you can just trade it to your old phone and take new phone. So something like that. So you want to keep upgrading your knowledge, you have to keep getting the newer models that are trained on more latest information. Okay. And then
one question to continue to that. So let's say it keeps on updating, right? Like the LLMs keeps on updating every year or every 6 months. The new versions comes up and everything. Let's say I build up an application using some LLM. Oh, I like if I get a push or something like, okay, no, I have to use another new model came up again, I have to upgrade. So is there any easy way to upgrade within the applications once it's developed, or it's a big task again?
absolutely, it's upgrading. It's not a software at all. It's just changing your API endpoint. That's it.
Okay, got it.
Okay.
Yeah.
So
Yeah.
all you have to do is change your endpoint to the new model name. That's it.
Okay, got it.
Yeah, I have one question. Sorry for asking.
Yeah, no, go ahead, please.
So what I understand, LLM is like a brain or something, intelligence, right? So, but
Right.
you're saying we are getting the data from the vector database. If you
Right.
want to update the data, why we need to update LLM? We need to add the data in the vector database parallelly or some from external sources, right? So that way we can get the up-to-date data, right?
Yes, your vector database is always up to date, but your vector database has only your internal data. You want to put your own data. You don't want to put the entire world's knowledge into the.
Yeah.
See,
For example, you
simple
asked about
question,
the hard
right?
data.
Let's say there is an IPL 2025 happened.
Okay.
Okay. I want to ask a question to the LLM about IPL 2025. It does not have that knowledge because it was cut off 22 or 23 it released, or 24 it released. Now, in a company, give me 1 minute. So in a company, if I want to implement RAG, I will talk about my data, my policies. I will not add information about IPL 2025 in my organizational database, right? So I only add specific information that I need. It's a company organizational application. Now, if I want LLM to answer that, there are two ways. One, I add the tools and give it web knowledge. It can go and search the web and give you about 2025. Or I take newer model, which is released maybe next year, then it can answer on its own. Okay. Yeah. Now you have another question?
Yeah, fine.
Okay. So don't worry. We will see what I'm going to try here. Yeah.
Can you go back to the screen? the slide.
Mhm.
Here in the LLM will answer based on the relevant data. But to filter the relevant data from the vector database, who will help? Is it the filtering also will be taken care by LLM or any other
No,
process?
this is the retriever we are having, right? So all of this is having here. We will use the retriever to go search the database and get the data out.
So retriever means, is it a custom program we will write?
Yeah, it's just a program. We are
Okay.
getting into it. Wait, so I have all of this here, okay?
Got it.
We'll go through all of this. Now, before going that, let's say I want to,
Harun?
yeah,
Sorry, I need to ask a follow-up question to this LLM trainings, right? So this differs from on-prem to SaaS models. Like so, OpenAI, there the retrainings of the model is their responsibility. But if it is something like Llama, which I can put on my on-prem, that I can train the LLM model with my data, right? That's my
yes,
responsibility. Okay.
yes. Yeah, if it's an open source Llama, you can install, you can download and have it on your own. So it's your own. You can train it. You have resources. You have information. You have time, money, and other resources. You can train your own model. The risk on that, I wouldn't say risk, but the cons of it is you cannot again take a newer version of the Llama and replace it because all your training is gone. Your training is on the
that's
older
correct.
model. Then you have to redo the training again on the newer model. Everything you have to repeat. Okay, so let's see. So I have the openai.com. I went here, openai.com, and then I go to developers. Then I have an API platform and API pricing. Okay, so I go API platform here. So you have all of these models. Then you have this price, right? Input 1.25, output $10 for 1 million tokens. Okay. Input is 0.25, output is $2 per 1 million tokens. So whatever that, they all have. Once you create an account here in this, you can go and create a API key. Okay. API pricing.
A basic question. Why input and output are separate charges? For our input only, they are processing and giving the output, right?
They are charged differently. That's how it is. Input and output, basically input also, it says how many words that you can send to LLM to read and understand. That is also processing. Generating output is also processing. So both, it's like our older phones, right? Earlier, both incoming call and outgoing calls were charged. Okay, but they were charged differently. Later, incoming became free, only outgoing was charged.
So it's not considered as a one token, as a one input and one output.
One word is one token.
One word, okay.
Yeah. So if you give 100 words, it's 100 tokens. And if the response gives you 1,000 words, it's 1,000 tokens. It's total 1,000. The 1,000 tokens that output is comes out, it will be charged.
Okay, if we didn't limit the output, then we'll be spending more money.
Sorry?
If we didn't limit the output, which is coming from ChatGPT,
Yes.
we will be spending a lot of money. Yeah.
Yes. Yeah. That's why you said like we do the rate limit. So we can put it in the in your system instructions. You can say generate the response. Do not provide more than 10,000 tokens or 1,000 tokens, kind of a thing.
Got it.
Okay. Yeah. So if you come here, platform, OpenAI, docs, overview. This is a rate limits. Okay, let me check here. API reference. I think this is the best way to go here, create an, where it goes, yeah, platform.openai.com/API keys. Just go and create a new key, give the name and provide this, and then you get the key here. Let me see. Test, create secret key. So you get this key and then you can use it. Okay. Now, usage, you will see the usage here. You can track. We'll talk about this all later. I don't know where you have to give the account details somewhere and then provide the credit card details for payment. Let me check and then I will give you the, should be somewhere here. I'll give you the screenshots. It's just like creating an account and giving your credit card or whatever details for the API keys. That should be.
Is there a trial?
Maybe. I'm not sure. Let me see. This is all the pricing. Yeah, this is the project you can see. And this is the API keys that I generated. Okay. And there's a billing here. This is the credit balance. So payment method, billing history, everything will be here. You just provide a payment method and then you can start using that. Okay. Maximum usage is $120. You can just put $10 and then put an add alert to this 80%, 100%, whatever. Okay. So this is what I created today, the test key. This is the old one. So if you go to usage, you can see what is the usage for your API keys. 0. (919) to 1004. It's 0. Default project. This is, I think, the new project. But you can see all of this here. So this is how you just create a key and then you can start using that key. So I'll show you how to use those keys here. Okay. Now let's get back. So we have this LangChain. So LangChain you must have used. So basically it's a framework, okay, or a LangChain Academy, which is used to stitch all of these components of the GenAI. Okay, your like whatever RAG architecture we are seeing, how do you stitch all of these? So you have this framework called LangChain. The LangChain has some libraries and functions, retrievers to connect all of these and then build your RAG architecture. We will also talk more about LangChain when we go ahead. There is a Langsmith, which is part of LangChain for monitoring. There's LangGraph, which is agentic application to build. And then there is a LangServe for deployment. So all of that we will talk about. But LangChain is the most popular framework used to connect all of these RAG frameworks. We install these libraries, okay, LangChain OpenAI, just the LangChain OpenAI. And then I have this OpenAI API key. So whatever key that we have generated here, so we can take just that key and come here. So we see the keys here, you can put and then put the name. So OpenAI API key, and then add your key here and save it. So this blue tick shows that this key is accessible from this notebook in this session. So you can access this. And then I have a lot of all of these keys where we want to use in the training. So for now, we are using OpenAI API key. So this is the key. And we also use Pinecone. So that I will show you when you use the Pinecone. So there you set up that keys. And this is the standard template, boilerplate code, how to access your key. You just have to say from Google Colab, import user data. Normally in the organizations, you have your, as I said, your HashiCorp secrets or every platform has this vault or secrets. You store it there and then you retrieve it from there. Either auth key or whatever, your organization will provide you the keys or you access from the vault and then put it here. Here you get user data.get. What is your key name? You get that. And then you assign it to your environment variable, os.environment, OpenAPI key. So once you set this, okay, all through your program, your OpenAI key will be available to the application. It can directly connect using that API key.
Hey,
Now
I have a big question. Since we are talking about keys, right? I just have one question. These are what open client ID and secret, right?
Yes.
Is there, from the security point of view, right? There's quite a bit of challenge because you have to constantly keep changing these open ID secrets and client ID secrets, client ID and the secret, right? Is there any other seamless way of integrating applications rather than having these keys, managing the keys?
No, so this is open source. You can directly connect with a key. As I said, this is not the same, does not give you same security as in your internal organization applications. They already have this deployed on their network, and then it is behind some other authentication. So only your SSO authentication, once you go through and then you give the internal authentication key, you will be able to connect to that endpoint, internal endpoint. Okay. From there, it connects to the LLM. So there is another layer of authentication that is built in within the organizations where you connect to an internal endpoint for the OpenAI, and then further it connects to the OpenAI, LLM model.
Yeah, understood that. I think my question is more of off topic here, right? Maybe I'll talk to you separately offline. Because I'm trying to holistically understand how best I can move away from this. Is there any other mechanism so that I can have a seamless integration between both applications and move away from these client ID and secret management concept, right? So it's becoming overhead in some cases in my day-to-day life, professionally. So that's the reason I'm trying to look at is there a way how
Yeah, we can talk about it. So normally in our organization also, what we do to connect is basically the auth key for the internal endpoint. So there is an SSO authentication, and then there is an auth key to connect to the internal endpoint API. It's internal API. That's all you need. How the internal endpoint is connected to the LLM is all it's all obscured. You cannot see how it is connected. So it's basically on-prem, like Azure OpenAI. But you only get to connect to one internal endpoint, not directly to the OpenAI endpoint. Okay, yeah, we'll talk about it. That's fine. So for now,
Okay, sure.
you want to understand how to connect to an LLM is using this key. This is already there here, and then you can directly connect. So we are creating the LLM reference to our LLM here from chat OpenAI. So this is the function you get from the library, okay? Chat OpenAI. And then you have all of these optional and mandatory parameters that you want to provide. Some of the mandatory ones you do is the model. Which model you want to connect from the OpenAI, okay? So here I am connecting to GPT-4o. So if you go here in the API reference, you will see where is that? Look at the pricing API keys and pricing we looked at. So there are different models that you connect to, right? Yeah. So these are all the models that you can connect from your application. So what you need to give, you just give the model name here. So what is the model name? These are the model names. Okay. So I am connecting to GPT-4o mini. This is the model I am connecting to. So you just change, sorry, GPT-4o, not mini. So I am connecting to GPT-4o. I don't know where that is. Yeah, this one, GPT-4o. So you can connect to any of these models from here, to understand, to use that model. As you said, right? So how can I change the model? All you need to do is switch the model name here. That's it. So it will go and connect to a different model name. Temperature max tokens. So max tokens is none here. This is where you do the rate limiting we talked about, right? So how do I control how many tokens that it can send? So here you can set, 100 max tokens is 100. So it will not give you more than 100 tokens. Timeout you can put, say if it does not respond between 1 second or 500 milliseconds, abandon it. You can put that. Max retries. This is not applied here, but how many times the model can try. You can call the model to try and answer it. API key you can provide here, or you have already set it to the environment. You don't need to put here. It will automatically take. And there are some few other parameters that we don't need to look at right now. But basically, this is your model, LLM model that is ready to integrate with your RAG architecture. Now, we don't have RAG here. If you see, I've not created any RAG. I'm just trying to first talk to a model using the API. So right now, the last 4 sessions, okay, we used embedding models. That is a different thing. But we looked at how we can connect to ChatGPT, correct? And ChatGPT is an application. We are typing, it gives answers. It's already connected to web. It has tools and all of that. Now, here I am talking to the LLM using a API. Okay. So this is how I'm getting connected to the LLM with the key and then asking me question to answer. So now I run this. Now my LLM reference is here. So if I use this LLM, it's going to connect to this model. Okay. Now I go here. Did I change the keys? No. Okay, let's see. And then I say dot invoke invoke the LLM model with this question, and you get the answer from the model. Now, what is the difference between this and ChatGPT? Right? It's the same thing. You are asking a question, you are getting back, but here you are talking to the LLM directly through an API. ChatGPT is an application, a chatbot. Now, if I ask the question, how is weather today in Dallas, to this model, LLM model, it is not able to provide real-time weather updates. So you can check with reliable weather, which says that you are now talking to a raw application, so raw model, LLM model, which has a cutoff date. So it cannot answer any question related to the current affairs, today's or recent date information, any question related to the recent events. Okay, so that is the limitation. Now you can see, in reality. So what is the limitation of the model? Sometimes it might hallucinate, but this is the exact behavior, expected behavior for the LLM. Okay, now we wanted to create we talked about a prompt template, right? So this is your prompt template. All you can do is it's a list of information. So one element here is your system, which is your system message. We are saying you are a helpful assistant that translates English to French. Translate the user sentence. Now, the next input here is human. I love programming. So there are two sets of instructions that I have added in this template, system and human. Now, when I ask LLM.invoke, it knows what is the question and what is the instruction based on this key. Okay. It is not trying to answer this. It's trying to answer, it should answer this based on this instruction. Here, I only said I love programming. There is no question here. So the LLM, what should we do with this information? I love programming. Okay, you love programming. So what do you want me to do? That comes from your system prompt, where you're giving a role saying that, hey, your LLM, you are an assistant that translates English to French. Now your model has assumed that role. Now it knows whatever you throw at me, I will not answer. I will just translate it from English to French. So now, if I run the same, okay, this question, what is the question? I love programming. Okay, it converts. So you get the AI message, the third part, right? We said the system message, the human message, and the system AI message. AI message is actually the response that LLM model sends you. The content is the answer. So J. Adorla programmation is the translated from English to French. Now the question, there is no question here. I just gave a statement. It gave me the answer. I can just print this. Now, if I ask this question here, right? So what is the capital of France? The same question. If I change this and then change this question, what is the capital of France? What do you expect the answer?
Translating
Translate
it to
to
French.
French.
Right? So it will not answer the capital of France is Paris. Rather, it will just translate the question itself into the French. That's what the expected behavior that we are expecting. See, now it just translated the question as is into French. Okay. Now, how did it know that here it gave the answer directly from its own knowledge, but here it's doing the translation because we have given instructions at the system level that, hey, this is your role and this is what you're supposed to do. Whatever the questions are sent to you, this is what you're supposed to do with the questions. Now we have kind of changed the behavior of the model. here. Okay, so this is what you call your system prompts to set up the role of your model. So this will help in some places, right? So let's say you have built an application for internal use only to help your employees with Spanish. Okay, if somebody is sending Spanish questions or about it, you want them to translate. Of course, there are a lot of Google translators, all of that. That's not the question scope here. Now, if you give the system prompt, the users will be able to only use it for that purpose, nothing else. So you can restrict the behavior or restrict the usage and dictate the behavior of the model lines. Okay, that's the question. Now we want to, because it's a template, we use a standard template, chat prompt template, and put the variables in this. So chat prompt template, we create a prompt from the template, and same we have system and human, but now we are having the dynamically changed, we are parameterizing it, input language, output language. Now it's no more English to French. It can, from any language to any language, it can translate, but it can only translate. It does not, still cannot answer the question. And human is another input. Okay, so I can just say, instead of input, say question. Okay, and then I pass the question. So this is the prompt template. Chain is, as I said, LangChain has a chain where you connect these pipes. There are different ways of building the applications. So here I am connecting this prompt template to the model and getting the chain and invoking the chain. Earlier, I was just directly invoking the LLM model with my question, but since I have a prompt, I bind that prompt to the model, and then it's a chain. Now I run the chain. So when I run the chain, the inputs, the parameters will first go into the prompt. They replace here. Then this prompt is sent to the LLM. So I want to convert French to Arabic, and this is the question. So this is in French, right? So this French, I want to convert to Arabic, or I want to convert to English. I can change anything here and then run this. See, now it converted French to English. Input language is French, output language is English. And this is the question. So it's still only doing the translation. So this is how you kind of communicate with your LLM using the API key. You got it?
Yep.
Okay, awesome. Now that we have built this, we will go and build our RAG, complete RAG. Same thing. Yes, Vinay.
Hey, Harun. Like in the previous collab, which you shown, there is a term called temperature. So what does that temperature mean?
So temperature basically is a parameter that there are some, on the LLM model, there are some options that you can use. So temperature is basically how varied your responses you want to be, or how narrow your answers to be, basically, because an LLM has wide knowledge of topics and information. If you want more creative answers, you can put a high temperature. If you want very specific answers, you can put the temperature to 0. Exact answers or very close to facts you want, you can put 0. Or you can put 10, 90, 57, or 1, I think 1 to 10. So you can put 0.7, 0.9 or something, where your answers will have a variety. It's kind of varied answers. Creative, you are creative, then your answers are very different from each other. But if you put 0, it's very specific, very fine-tuned, or kind of focused answers that you will get. So that's one of the parameter you can use.
Thank you. So I have one more question. I don't know whether it is relevant or irrelevant.
Sure.
Let's say now the input we have given as I love programming, hello, good morning, whatever like if I gave input which is hate speech or a vulgar language or a hatred towards something or someone, so which is not that this information which is not there in the input documents and all. So now all this hate speech and all, will the LLM process that, or like how
Yes.
it,
Yeah. So good question. So we have a session on that towards the end of the training. It's called guardrails. Okay. Most of the models have already implemented guardrails. Even if you ask ChatGPT, it's not going to give you an answer. It says I'm not allowed to answer these kind of questions, any political, any sexual or any hate speech or anything racist, things. It's not. It has a guardrails, so it can detect and say I cannot answer this type of questions or whatever. On top of that, you can also write your own guardrails. Okay? And you have frameworks where you can implement your guardrails and add it to your application. So both your input is scanned before sending it to the LLM model, and the output is scanned from the LLM, whatever you get, that is scanned before sending it to the user. So though you can put your guardrails both at the input and output. There are some frameworks we'll discuss in session 13, 14, 15, around that. Towards the last 3-4 sessions, we will talk about all of these. And guardrails is one of the topic that we will talk. We will implement same thing. We will add and we'll see what. Not just this hate speech, also how do you protect your personal information? Like if there is an SSN number, or if it is a phone number or email or date of birth that you don't want to expose in any of the answers to the user, you can also create a guardrail for that and protect it. Okay, PII information.
thank you.
Yeah, awesome. All right. So I have this same thing we did last week using Pinecone. We wanted to start. We built a semantic search application, right? So using the resume, I was able to throw it, and it gave me some chunks, right? So I'm continuing from there basically, and then we'll try to add the last component to it and see how things will become more, clear and convenient for the user language. So this is all the same notebook, OpenAI embeddings document. I have PyPDF loader, text splitter to cut it into chunks, grant access. Okay, grant access. Okay, the file is not available. Okay, we'll add. So OpenAI embeddings I'm using for the embedding model. So I think you still remember this, right? So this is the resume I have. Extraction, I use PyPDF loader to load, and text splitter to cut it into chunks. And for the embedding here, I'm using OpenAI embeddings. Vector stores, I'm using FastDB again as a vector database. So I think there is a Pinecone also. We'll look at it. But this is for using FastDB and GPT-4. So here, the memory and retrieval chain, chat OpenAI for template, buffer memory is internal memory that we use. And same thing here, I'm getting OpenAI key setting it here, and I'm adding this resume. We don't have it here. We'll go and upload the file from here. Use the same resume document. Load the file using that path. Cut it into a chunks of 1000. Overlap is 0. We are not doing any overlap here. We can change it. We can have a 10 characters overlap or 100 characters overlap. And then split the documents. Get OpenAI embeddings. So we're using the default model, which is, I think, ADA 002, and creating a vector store with 5dB using these chunks and embeddings that we have. Okay, now it is done. So this is the first chunk it has. Okay. Model name is GPT-4. So now I'm creating the last part, the LLM model, temperature 0.7, model GPT-4. Let's reduce the temperature. This one, creating a memory, chart history memory. So these are all standard. So you don't need to worry how to use this, what is this. So these are standard functions that you can use. But the only thing is, yes, you have created an LLM here. You have created the semantic search, the vector store with all of these chunks. It's all in there. Okay. Now I'm building this retrieval chain from LLM. What is my model? This is my LLM model. This is chain type stuff. Retriever is vector store as retriever. What is vector store? This is my 5dB is my vector store. So from this vector store, where I have stored my chunks and documents, I am getting a retriever object, which is used to search. So I have a LLM model, I have a retriever, both here, all under the chain. So once this chain is built, I can execute the chain with any of my questions. So result conversation chain, the question is my query. What is the query? Skills, tools, and technologies. Okay. So if I run this, okay. See, now the answer you got last week was just these chunks, right? So it'll give you 3 or 4 chunks like this. It doesn't make any sense. Now the same chunks is what is sent to LLM. Okay, here I have added the LLM to the chain. Okay, the retriever will get all this, and then I have the LLM model here, which it can take results from this retriever. So it's all in the same chain. So this basically, this all chain is now built in. So the retriever will take the question, get it response, get the relevant data, and then it is chained to LLM. So LLM will get query and relevant data, everything. So all of that is chained here. Now, if I run this, I get the exact answer in the English language. Okay. The answer is the individual has experience with following skills, tools, and technologies. So it put it in data platforms, data pipelines, AI, vector databases, cloud platforms, AI tools. So all of that it has found in the resume. So it's so if I ask about certification and badges, okay, then it will pull all of that information retriever again. But see here how it has formatted your answer. Has received the following certification and badges with this. Let us first go here and go back to session 4, where we built our RAG application. We'll go to Pinecone. It doesn't matter which vector database, right? Now let's say, let me run this. Or if I have already. Okay. See, the question here is, what are the projects executed? Now the answer you see is like this, right? So it's just throwing you some information like this. Okay? It does not give you a very correct answer to the question. It's throwing the relevant paragraphs from the resume where you can find your projects. So you can see here, managing large-scale digital transformation projects. This is one. This programming skills here. Processing using Apache Kafka and PySpark. Develop, deployed PySpark. So this is bits and pieces of information, but it does not have a complete answer that you can clearly understand what are the projects. Okay. Now, if you ask the same question here, summarize the projects in 10 lines, format response in bullet points. So before going there, okay, so let's say I asked about certifications and badges. It gave me this, okay, very neat in 10 bullet points. I asked, you have only 9. So I didn't ask anything here, but it kind of put it in the bullet points. Now, if I ask this query, who is the issuer of information security policy? Now it says the text does not provide information on who issued the information security policy, because there is nothing in the resume that's talking about information security policy. I have never asked, I have never worked, there is no reference to it. There are no results, or it gave some irrelevant results to the LLM. It went through all of those results. It couldn't find anything about the information security policy. So it responds saying that the text you provided me from the retriever, it does not have anything about information security policy. Okay, this says that it does not have that knowledge. But if you can ask the model to answer from its own knowledge, it can. But then again, what information security policy are you talking about? There are millions in general world. It can throw something about, and it can hallucinate and send you something, blabber something about it, but it will not be very helpful. Okay. Now, to understand the scope of RAG, we are asking it to answer only from this retrieved results that we send it. Now, if I ask this question, summarize the projects in 10 lines, format response in bullet points, the same question I'm asking about the projects. I asked about the projects here, so I got this kind of information. So I asked the same question here. See, now this is how it formats your answer. Again, based on this kind of input. First, it will call this. It gets all of this information. It reads it and formats it in a proper format for you to understand what are the projects that are summarized. Developed an AI-powered match-merge solution using advanced LLMs and integrated vector search technologies for efficient similarity search and duplication detection. Designed RAG application to healthcare data needs. Built DLT pipelines and Databricks, blah, blah, blah. All of this is restored, transformed using Databricks. So all of these projects, it has summarized, in 10 lines. So this is the power of LLMs, the model that you use with RAG. Without RAG, you get raw data, but you feed that raw data and ask it to process and package it in a neat way. So this is what you get the output from the RAG application. This is the complete with LLM model. Now you understood why we need, there are questions. We are getting already the results here, why we need an LLM again here, right? So this is the difference in the output. Okay. Now that is the building of RAG. We have more use cases or more programs. Tomorrow we'll continue with more code. I don't want to overwhelm you with a lot of applications, but this is it. So we can discuss, answer questions based on this. So we have another 10 minutes. We can talk about this.
Ted, can you
Yes,
explain the memory
I
key?
have one
I
question.
missed
Yeah.
it.
One at a time. So who's gonna go first? I'm gonna go first.
Yeah, I'll go first, Sayed.
Okay,
I
go
missed the
for
memory key. Can you explain what is memory key and then what are the different type of values we have to feed for the memory key?
Good question.
Yeah, there. 6.
Oh, this one, right?
Yeah.
This is just we are using chat history here in the buffer, whatever is the buffer that we are using. So basically, we don't have the thread here. It's like just like continuing the conversation in the thread, whatever questions you have asked earlier. So what are different types of memory key here? You can use history, you can use chat history, or you can use any of the caching databases that you want to get from there, extract and use that as your memory key.
So those are
Complete
predefined values,
list.
we have to pass it. It's not a random value. Something.
No, it's not a random value. So you can go so if you go to source conversation buffer memory, so this is the code. You can go to documentation and check string buffer of memory. Memory key, load memory variables. So if you're storing that everything in a variable in a string, you can load that everything when you're sending it to the LLM, so that all the context is synced. So basically, when you're getting the answer from the LLM, you can add it to your chat, memory string. Okay, and next time when you send it, the previous answer will also go to the LLM. How to maintain the chat conversation thread.
Got it. It's mainly for context purpose, right?
Context purpose, yes. It's to maintain the history, previous history, like you're doing if you go to chat GPT application, so you can ask follow-up questions based on your previous question and answer. Most of the times it will suggest you, do you want this? Do you want me to do this? You just say yes or no. And then just you type yes, it will understand what you want to do, and then it will continue from the previous answer, right? So once you ask a question, it gives a whole lot of text. Then it will ask, do you want me to convert this into a presentation slide or into a document? All you have to do is yes. So then it'll go back and say, take all that content and generate the document and then give you, hey, this is where your document is, you take it. Okay. So that's how you maintain the memory thread or buffer. Okay.
Arun, then this is the parameter for the is this parameter for the LLM or is it parameter of the long chain or such framework? I believe long chain, right? Is that
No,
right?
LLM itself will not have any memory.
Yeah, that's what I
It's
was
all in the context. You're all storing in the context window. Context window is, LLM is like, it's agnostic. You cannot make any changes to it directly. It has only some previous parameters that it can use it when responding. But any other information is all in that particular context window. That's why your context windows are very important. How much information can you provide all of these, your RAG results are also going into the same context window. You cannot send like 1 GB or 2 GB of data as a retrieved results to the LLM model. So it has limitations on how much it can process and understand to answer a question within that context window. So the windows are like, yeah, it's pretty big now, like 128 MB or something that it can hold. A million tokens or something it can hold the context window to answer your question. Okay? Beyond that, it will throw rate limit issue or something like that. So the whole point of then you have to go back and tune your retriever. How much results are you getting? Why are you getting a how 1 GB of information from vector database that is you're dumping to your LLM, right? So that is your context window. How much retrieved results are you passing through the LLM? Then apart from retrieved results, you will also have your user query, you will also have your guardrails, you will also have your system prompts, everything going to the LLM, right? So based on all of that, instructions, context, retrieved results, question, it will go through all of that, understand, and then give you the response. Okay? Yeah.
I have a question.
Sayed?
Question. Yeah.
Yeah. So the question I have is like, so in this example, we are just dealing with small documents, right? Like less documents, but in traditional use cases, we have lots and lots of data, and if we keep on adding that to the vector database, won't it get overloaded, or like it's again we are trying to build up a big data system over there, right?
Yes. Your vector databases are your knowledge stores.
Okay.
It can go to 100 GB.
Oh, okay. Got it.
Yes.
Okay. So we keep
Depends.
on. Uh-huh.
It depends on what kind of information you want to put on the vector database. So basically, if it is about your HR policies, I don't think it is more than 1 GB of data. If you want to put all your financial data, transactional data, right, then it goes into GBs because you're trying to dump all your say orders. So suppose you're building a chatbot for customer support who can come and check their order status.
Right.
Now you have to continuously keep updating all the orders, all the customers, all the invoices, complete order system data. So it can easily go into GBs, right? Now,
okay, got it.
How
Yep.
robust is your vector database? In that case,
Yep.
just like you select a Pinecone or you select a VBA specialty vector databases where it is like which can scale and be fast enough to respond, right? And you create separate collections within the vector database if you want to. So when you hit a collection, you know which collection you are hitting. So it's kind of your what you call partitions, right? So that's how you divide your data. So you can create different multiple collections and then get the data. That's why there is a RAG, hybrid RAG also they call. You can filter some of the traditional data and then combine it with the RAG data. Say for example, I'm talking about order status. I need only status of the orders, but whose order is that? I also need a customer information. Somebody is asking, I cannot give him all the order information of somebody else. So how do I handle that? So just for that purpose, do I want to put customer data also in the vector database? I may not need to. So what I will do, I will get customer data information from my regular SQL database and then try to combine it within the retriever or in the LLM. I send both order status, order information, and the customer information and say, hey, only respond with the orders of this customer that I am giving you here. So that's hybrid RAG. I'm combining results from both my SQL. I put a where clause using the customer because when the customer asks the question, you ask for his name or ID or whatever information, account ID or whatever. So using that information, I filter combine it with what I'm getting from the RAG, filter it, combine both as a hybrid RAG, and then send it to the LLM to respond.
Yep. Okay. Thanks. This is the exact information I was looking for. Actually, I was a little bit confused, but I think I can connect the dots now.
Awesome. Super. Glad. All
So
right.
yes, there are
Yeah. Any other
one
questions?
more
Yes,
question.
go.
There are
Yeah.
parameters like a system and human you mentioned, right? System I clearly understand to control the behavior of the LLM, but do we have any other parameter that also we can add more control or behavior of the LLM similar to system and
There
human?
are
Anything
only
else?
3 parameters as far as I know. The system, human, and AI message. Okay. System is your instructions and your context. Human is the question that you are asking, and AI message is your chain of the previous conversation. So you can keep adding your AI response back to your prompt template in the AI message. So it kind of gets all the context, what was the previous answer, and then what is the current question. So it's the same kind of chatbot experience that you're trying to replicate using that. So
The
there are only
conversation
3
chain.
parameters that you can use.
So the conversation chain will take care of the AI message, the third parameter you're saying.
Yes. Yeah. So it will AI message is actually, so let's think about if you have worked in the API, right? So there are 2-factor authentication. The first you make a call to the API to get a token, right? And the second call you make to the API, you embed that token, send that token back to authenticate. Hey, I got a new token. The session is valid. Use this token and then give me the response to the API. Now, if that token is expired, then you have to first make a call to get a token and then send the API response back again. So same thing. What you will do is you ask a question, you get a response. AI message is the response. You store that API response, and then next time when you call the API, you add that AI message also back to the template. The second answer you get, again, you append that message to the AI message so that all that history is stored, is maintained in the AI message. Now that will again get you to the token levels, the context windows. If you keep continuing, just like your chat GPT, the more and more you keep adding the conversation, the number of tokens, it's going to basically say, hey, you're running out of your context window. And every time you send to LLM, it is all charged, all the tokens. So that's why it's mostly like idempotent. It does not have a state. You ask a question, you get your answer, you're done. You cannot ask follow-up questions if you don't build that conversation history or memory buffer. So to improve the token counts, to improve the conversation, see, conversations are mostly in the chatbot and not in the RAG. So RAG you can use for a chatbot. If you want to, you have to implement that conversation history yourself. You can cache it in a different database, filter it, or you can feed it back all the conversation to the LLM to ask the follow-up questions. And then you can create threads, basically. So in the application, so each thread of conversation ID will tell you, which conversation you are having. Just like in ChatGPT, you have different projects or different chats, right? So you open that chat, you are connected to that history.
So in our current scenario, the context is not built based on our history of questions.
Yes.
Okay.
Yeah, here I'm not sending any of the AI message back in the template. It's only the output that I'm getting in the AI message. Okay. Sure.
Actually, I have one question. So how can we limit the output here? So while performing search in RAG or actually while performing search in LLM?
RAG you cannot. So RAG is just retriever. You can, in the RAG you have a number of results that you want to get from the retriever. Okay. So
Okay.
if you search here in the files DB from the retriever, you can limit how many results that you want to get from the retriever. Okay, so this here you can say I want 3 results, I want 5 results, I want 10 results that you can get. Okay, then you can also set I want to get only the threshold limit similarity score of less than 0.5 or more than 75% or more than 90% only I want to get. So those parameters, it's like search parameters that you can do when you want to do a retriever with the database. We looked at these parameters here when we did this, right? Vector search. We did this here. We got night score. Yeah, so see end results when you are querying, we can limit here how many results. So each library will have a different implementation of how to pass the parameter. But yes, you can limit both on number of results that you want to get from the vector database and also the score. Since it has, see here, it has a score, right? 0.59, 0.69. You can also limit based on the similarity score. I want only the ones which are very close, less than 0.3 distance, or the score is very high, similarity score. So you can limit based on those two parameters.
So once we limit actually, and I mean drag search, drag query, so we'll get whatever the result, just we are going to feed that result to LLM. So we'll
Yes.
limit result from LLM as well in that case.
Yeah, so that you are limiting the inputs from here, from the vector database. Okay.
Okay.
Now the output you can directly set with the LLM that you are when you are passing the prompt. In the prompt itself, you can send when you are creating the LLM, you can set what is the rate limit, number of tokens that you are expecting.
Okay. Yeah.
That parameter you can set when you are creating the LLM here. Let's look at LLM.
Or in the system prompt itself, we can set this, right, Sagar?
Yeah, you can set it in the system prompt. It will understand. You can also set it up. Here, if you see here also, you can set up max tokens to 100.
If we set actually max tokens here at system prompt, actually the rag search will give all the results, and that will LLM will limit, right? Or how that will behave?
Sorry, what is that?
If you set actually that limit at system prompt level, so we are going to get all the data from RAG, and the LLM will limit, right? So while giving the output.
Yeah, input is at the RAG level. That goes as input to LLM in the context that you have to set based on how you are filtering the data, how many parameters that you're getting. But once it goes into the LLM, it reads all of that. The output it is generating, you can restrict here. See, I put max tokens 2 here. Then I didn't get the complete answer. I got only the capital. So it cut off the answer here. Okay. So I get five tokens. I will get only 5 tokens. So 1, 2, 3, 4, 5. That's it. So this is how you control how many tokens you want the the response. You want to get the response from the LLM. Normally, in all of our organizations, this is already set. So, it's very inconvenient because the problem is it does not summarize within 10 tokens. It will just cut off at 10 tokens.
Yes.
Okay. Then you have to give special instructions. So you have to say when you are responding, summarize the answer within the maximum number of tokens. Something like that. You have to tell the LLM, hey, I have a max token limit. So whatever you answer, you better try to summarize within those number of words rather than just getting the answer and then it's cutting off, whatever the response here. In our company also, when we try, it's like 10,000 tokens, but the LLM does not know. It starts generating pages and pages of output, and suddenly, after 4 or 5 pages, stops saying I have reached the limit. So your output is not comprehensive, basically. So that's you have to handle based on max number of tokens. You have to give again in the system prompt, hey, this is my max tokens, or even if you don't know the exact number of tokens, you can add an instruction. Make sure you summarize all the important information within the maximum number of tokens. So it would understand and then rewrite. Okay.
Yeah.
And then, so let's say I have, let's try to do some here. Just the two. So let's say just the capital here. Okay. Now what I will
So
do.
actually, when we give the two sentences, I mean two tokens, it's supposed to be just France, right? So
Exactly.
that's less than one. Why it is giving that capital? Is it possible to tune this model?
That is what I'm talking about, right? In the system prompt.
Yes.
So it should give Paris. Okay, within the two tokens, it should actually give me the answer. But rather, what it is doing is it's generating the answer first and then cutting off based on the number of tokens. Okay, so what we can do here, I don't know, I'm just trying. Let's try. We don't know how it behaves. It's all right. So in the system message, I will say instead of this, make sure the answer is prioritized and complete within the max token limit mentioned. Okay, let's say if I give this message here and then invoke, no, it doesn't work. Still says the capital. Okay, or answer the question in just one word. If I give this kind of, see now it gives Paris.
Yes.
So basically, this is how, the power of prompt engineering, right? So what kind of prompts are you giving it to the LLM model to understand? Okay. Now, this is one way of limiting the cutoff, right? So here, it's just cut off. It does not generate more than that. It cuts off those number of tokens there. Now, here, you are actually giving instructions to make sure to summarize the answer within this limit, 1 word or 10 words or, whatever kind of a thing. So it's kind of a combination how your AI or model behaves and how you get it to pass the instructions, basically.
Yes, got it.
Okay.
Yes.
All right, guys. Yeah, I think we are 12 minutes over. Thank you so much. I appreciate your energy, effort. I hope you're getting value out of this. We will continue tomorrow. I encourage all of you to at least set up and then start running and doing these kind of things and see how it behaves. Okay. Now that you have the complete RAG application, I will ask you as an assignment or assessment, though we have to tomorrow as well, we'll do one more. But think of use case. Think of your own use cases. What kind of documents you want to put it in the RAG. Say you want to say 10 documents or 50 documents that you want to put in the RAG and use this RAG architecture, and what type of questions you would ask. Start building the application. So that's your first project, building a RAG application. Bring your own use cases, bring your sources. You want a customer support or legal documents or policy documents, what kind of documents you want to put in, how you want to see how the model answers. Okay. First thing, set up your OpenAI API key or any other key. So I use it because it's been there for last so many sessions, and it's not very expensive. So I just keep using it. I would recommend it shouldn't cost more than $10 for the entire thing. It depends on your usage again. But 1 million tokens is too huge. So I think it shouldn't be more, for now. Come up with the use case, write your use case, bring your sources, create the key, and start building. Use these notebooks as your starting point and start building. Most of it is here. You just need to change the source and change your keys, and then you should be good to start running this. Okay?
All right. Thank you.
Yeah, thank you so much. Yeah, let's meet
Thank you.
tomorrow. We'll continue with more tips and wrap
Thank
up.
you.
Thank you all. See you.
Bye.
Thank you.